Hello, it's Keith here, and this is lesson 19 of my Z80 programming tutorials. Now last week we had a look at how to use the AY sound chip on a variety of systems to create basic sounds, and we used this to create a simple driver called Chibi Sound, which would take a single byte value and create a various number of sound effects, including distortion sounds and low and high pitch basic sounds. So this week we're going to do the same, but this time we're going to do it on the Elan Enterprise. We're going to have a look at the various options that the Elan Enterprise's sound chip offers us, and also we're then going to recreate Chibi Sound on the Elan Enterprise, so we can create the same kind of sounds by passing the same values in the accumulator to our Chibi Sound driver, irrespective of the system it's on. So how does the Enterprise sound chip compare to the AY? Well, on the Amstrad CPC, the AY sound chip has very fixed panning. One channel's hard to the left, one channel's hard to the right, and one channel's in the center. The Enterprise allows you to specify specific volumes for all the left and right channels of all four sound channels. That's the 3 tone channels and the 1 noise channel, which gives more flexibility with regards to tone positioning. There is one disadvantage to the Enterprise, although it won't affect us with that Chibi Sound driver. The Elan Enterprise doesn't have the same options with regards to envelopes. So whereas the AY has relatively advanced envelopes, which is where the volume fades off over time or waves in and out, the Elan Enterprise doesn't offer that. So we do have more limited options there. But again, we don't use envelopes in Chibi Sound, so it's not going to be a major problem. When it came to programming the AY sound chip, we had to use 2 ports to control a register and then give a new value to that register. The AY sound chip had a variety of registers which defined the various tone options and also noise and of course envelopes and so on. Now the Enterprise also has some registers, we could call them, which define the sound effects that are being played. However, we don't have any registers that we have to select. We actually have a full set of ports, so each one of these attributes of the sound is an individual port, which makes it a little bit easier for us to control the Enterprise sound chip. And more significantly, whereas the AY sound chip was supported by a large number of systems, the Enterprise's sound chip is specific to the Enterprise, so there's no other systems that have this exact same sound chip. So let's make a start and let's have a look at the basics of the ports that are available to us. So you can see here they start at A0 and they go to AF, and of course we just write a new byte to these with an out command, and each one only takes a single byte. Now our tone is defined by 2 bytes, a low and a high. Now the high byte only uses 4 bits of the byte. The remaining 4 bits are used for what's known as a polynomial counter, a ring modulator and a high pass filter. Now these allow us to make some changes to the way the tone sounds. It's quite hard to explain these, so what I'd actually suggest you do is you actually have a play with them and just hear what they sound like, and we will do a bit of that later. So just have a play if you want to create your own sound and just see what sounds most appropriate for what you want to use it for. Now one important thing is the ring modulator and the high pass filter, when they're turned on channel 0, actually use the sound that's being played on one of the other channels as part of their input, even if that channel is muted. So for example, the ring modulator on channel 0 will use channel 2's tone, and the high pass filter on channel 0 will use channel 1's tone. So you can't use these independently. You do have to configure the other channels because they are basically used as an input filter to the primary channel that you've turned on. And to turn these on, you just set a bit in one of these to 1. If these bits are all 0, these will not be turned on. And of course that's the mode we're going to be using it in today. Now you also have a noise channel. Now you'll notice that the noise is entirely defined by a single byte, and you do have a few options here. Now the rightmost 2 bits are used to either select 31 kHz noise, which is white noise essentially, or you can link it to one of the other channels, and again this allows us to use the pitch of one of the other channels even if the channel is muted as the source for our noise. And this is how we're going to use it in Chibi Sound, where we want to be able to change the pitch of the noise depending on the byte we pass to Chibi Sound. Now next to that you have a polynomial counter again. Then you have a bit swap, which swaps bits 7 and 17 of the random noise generation, and the effect this actually has is it makes the noise sound more synthetic. We won't be using that. And then again you have high pass, a low pass, a high pass, and a ring modulator that can be turned on, but again we won't be using those. Now another option you have, which isn't particularly related to sound, is the interrupts, and these are our interrupt mode 1 type interrupts, which are the interrupts that fire on the system at regular intervals. Now 50 Hz would be the regular screen interrupt, but you can set other options, and you can even have the interrupt occur with a tone. Now beyond that, the Enterprise does have the capability of emulating a ZX Spectrum, and the ZX Spectrum the 48K ZX Spectrum has a rather nasty thing called the beeper speaker, which is about the lowest possible thing you can have, which is where you can just toggle the wave up or down and create a basic square wave with the detriment that you actually have to use pretty much all your processing power to do it. So you can turn on what's known as the DA ladder, which will turn some of the other ports into a spectrum emulation, albeit a stereo spectrum emulation, but still not something you really want to use. So we won't be using that today because we've got this far, far better enterprise sound chip. As I said, it's not quite as good as the AY arguably, but it is very powerful. So really we would be crazy to turn on that DA ladder. And then finally, you've got these hold options for the tones, which will just suspend the tone from playing. They're not very useful. The next bytes from A8 to AB are the left channel volumes, and then AC to AF are the right channel volumes. So lots of options there. Okay, well I think that's enough theory, so let's have a look at our code. So what we've got here is a very simple example. We've got various options here that we're writing to the ports, and we're going to play with a few of them and see what effect they have. So first of all, I'm just going to round out these options here because these are relating to the noise, and we don't want to use the noise just yet. Now for a bit of visual entertainment, we are going to use these. Here you can see we've got a spectrum analyzer, we've got an oscilloscope type effect, and we've also got a key detection routine here, which will show what note is being played. So these will give us a bit of a visual clue to what the sound is actually doing. So let's just fire up our emulator here and we'll see what happens. Now you can hear here, hopefully, that we've got a fairly high pitched tone. So you can see the waveform going up and down here, and you can see the pitch shown here. Now if I just close this, we'll have a look at what options we're using to create that tone. So we're using channel 0 for this tone, and you can see that the high bit here is all zeros and the low bit has some bits set, and then we're setting our volume to maximum. If we changed this bit here to 0, we would have reduced the volume by about half, and if we changed all of the bits to 0, then we would have effectively muted the channel. And if we just left that last bit of 0 as 1, that would be as quiet as possible. It'd be very quiet indeed. We probably wouldn't be able to hear it very well. So because we're using left and right channels, we're setting both channels to the same volume, which means of course that the channel will sound in the middle of the speakers. Now we are setting a tone 2 here, but we're never setting the volume, so it's not actually doing anything. And the reason we are doing that, is we are going to use channel 2 later for our noise effect. So we're not going to use that to play a tone, although it's very simple. We would just need to set the respective volume channels, but we're going to have some settings in there so we can play with our noise later. Let's just run that again very quickly so you can hear just once again what that sounded like. So that's quite a high pitched tone. Now what happens if we set the two bottommost bits to 1 here? Now you'll hear it's a much lower tone. And you can see the distance between the waves is now much wider, and this is far more visible. And basically what you'll see is the taller the waves are, the louder the sound is, and the wider the waves are, the lower pitch the sound is. And you will also have noticed there, as this number here gets higher, the pitch gets lower. So smaller numbers are higher pitch. And you can see now it's very, very big. So that's how the tone is affected by changing the pitch. So let's set it back to this, and let's have a play with some of the other options. So we had the polynomial counter, so if we just try that now. Now you'll see that the wave is now quite irregular and distorted, and that's what the polynomial counter has done to it. So maybe it sounds a bit more like an engine or something, so if you were doing a motorbike race game or something, that might be your engine sound. And that's kind of more like distortion almost. So again, you've got a lot of options here, and it can be quite difficult to work out what they're going to do. So as I say, you will probably want to just have an experiment and hear what the sounds do. Now, as I said before, the ring modulator and the high pass actually use the other channels as the input to the sound filter, and you can see that channel 0 will use channel 1 for the high pass and channel 2 for the ring modulator. So let's just have a go with that. So we'll just turn it off again just for a moment. So that's our unaltered tone. And let's turn the ring modulator on. And now you can hear it's very different. And as I said, the ring modulator uses channel 2. So let's have a play with channel 2 and see how that affects things. So if we just change these two to 0 and just put a 1 in here, that will change the frequency of channel 2 to a much higher frequency. And now you can see that the sound has changed very, very differently, because as I've said, channel 2 is being used as an input to that ring pass filter, to that ring modulator. Now, as well as the ring modulator, we can use the high pass filter, which will use channel 1. And let's just turn that off. So again, it is making some quite significant difference to the sound. So that's channel 0 in use. All the other channels do work the same. The only thing you need to bear in mind is they do use different channels for their input, and some of them even use the noise channel for input. So, well, how do we actually use the noise channel? Well, let's have a look at it. So you've got the noise channel down here. It's controlled by A6, and its tone volumes are changed by A, B and AF, and you can see these here. So we're just going to set it to maximum volume because we actually want to hear it do something. And we're going to turn off the volume for our channel 1, channel 0, so that we will only hear the noise. So let's start off with the noise using the 31 kilohertz option, so it's not linked to any other channel. So you can hear that's very loud. You can see it's a very fast noise, so to speak, and not very pleasant. But you know, that's a kind of waterfall sound or your distuned TV sound. So that's the when we've got these set to 0, which really just doesn't have any control at all. If we set this to 1, this will now link to our first tone channel. And let's just try that again. Now that's not really a noise effect at all. It's more like a distortion effect. And this is relating to the pitch of the first tone channel. So if I now change this to 0, we will now increase the pitch of the tone channel 0. And just to reiterate, you can't hear tone 0 because it's muted. And now the pitch has got a lot higher. And then if I change this to 0 as well, it will now be extremely high indeed. So that noise will be very, very fast. And we're pretty much back to our white noise there. So we'll set to the middle one because it's easier to hear. And we'll just play that again. So that's what it currently sounds like. Now let's turn on one of the other options. Let's turn on the swap of bit 7 and 17. Now this is related to the way that the random noise is generated, and if it should have the effect. Now hopefully you can hear that sounds much more synthetic and starts to sound more like a computer crashing than sort of a distortion or an explosion. So that's one option we've got, and we've also got the high pass and low pass and the polynomial again. So you can hear that there's some kind of pattern been introduced there by the ring filter there. So that's how we can set the noise and the tone channels. As I said before, the tone channels are all the same, and that's the noise. So how does this help us with regards to Chibi sound? Well, just to reiterate, Chibi sound will take a single byte as its input, and the byte is in the format of N, V, T, 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 T. Now these bits here are the tone, and these will give a tone from 1 to 63, with 1 being the highest tone and 63 being the lowest. V is the volume bit. If it's set to 1, the tone is loud. If it's set to 0, the tone is half the volume. And N is the noise bit. And if the noise bit is set, it will be a distorted sound. If it's not, it will be a clear tone. Now there's a special definition. If all of the bits are 0, so if A is 0, then all of the sounds are turned off. In all the other cases, the combination of these bits will change the tone, and the intention of Chibi Sound was it was used in Grime Z80, my little multi-platform Z80 project, and it created the sound effects. So the explosion sounds when you shot things, or this dying sound effect with the kind of distortion descending, and various beeps and things. So it's just a very simple driver to allow you to get some simple sounds into your game and allow you to make a multi-platform game that isn't completely silent. Do it very quickly. If you want to do something more advanced, you want to look at something like Arcus Player and Arcus Tracker. It is possible to use Arcus Player with an AY sound emulator, because Arcus is typically an AY system, but you can use this SimAmp driver, and you can download this off in my tutorials file, although I have to iterate, I can't take credit for it, I didn't write it. So the AY emulator is by Istan V, and it was converted by Geeko. It was, or Gecko maybe. It's part of SimAmp, but I was able to plug it into Arcus Tracker, Arcus Player, and this is what Chibi Akuma's used is on the Enterprise to play the sound. The sound slide's the sound is slightly different because, as I've said before, the Enterprise doesn't support envelopes, but generally it's very good, and it's a really fast way of getting your music working on a lot of systems. That said, let's have a look at Chibi Sound. So the first thing we do is we check if all the bits are 0. If they are, we jump to the silent option. This is going to turn off all of our sound, and on the Enterprise all we do is we mute all the channels by setting them all to 0. This turns the volume to 0, and this stops all the sound playing. Now there are 6 bits used for the tone. If it's not silent, we need to set channel 0 to those bits. So we take the rightmost 3 bits, shift them over to the leftmost area, and then set that to the low byte. And this will set the first part of our tone. The next 3 bits are the high 3 bits, and we want those to be on the right hand side of the high byte of the tone, and we just set that as well. Next we just pull back in the original byte that was passed to us because we store it temporarily in H. We then get the volume bit, and we shift that once to the right, and we store that at the end of this setting here. This will have the effect of either setting all of the bits to 1, meaning top volume, or if that bit was 0, setting all but the top bit to 1, meaning half volume. And then this is used for all of the volume channels. Now next we want to check if the noise bit is set, bit 7. If it is, then we carry on here. If not, then we return. Now if the noise bit is set, then we want to mute the tone channel, because we needed to set it because the tone channel is going to be used to define the pitch of the noise. But once we've done that, we do need to mute it if we're going to make a noise. Next we need to turn on the noise, and we need to tell it to use channel 0, and we do that by putting a 1 in here. The channels are usually defined as 0, 1 and 2, but numbers 1, 2 and 3 in the noise byte will define which channel the noise should get its settings from. And then we need to reset the volume of the noise channel here, and that's really all there is to it. And you can see there's a quick definition of all the options here. So, well, how does that sound? Well, let's have a go with it. So here you can hear a low pitch sound at full volume, and it's gradually increasing. And now it's getting quite high pitched indeed, and you can see it changing over here. Now when it gets to 40, it will start again at low volume. So even the low volume is still quite clear, because we were only having 2 volume options. It seems sensible to have a reasonably loud volume even for the low volume, because having something so quiet it was hardly there didn't make sense, but much quieter. And now we're into the noise section. And then again, much quieter. So you can see this is the byte that is being passed to the Chibi Sound in the accumulator, and you can hear and also of course see the sound is changing depending on that byte. So this is what Chibi Sound gives us. Very simple sound effects, but very convenient for the Z80 systems. And I'm currently in the process of rewriting Chibi Sound for the 68000 systems and the 6502 systems that I'm going to be covering next year. So Chibi Sound is going to be something that you're going to see again, and although it's very limited, I think it's good for the beginner gamer just looking to create some sound effects for their Space Invaders game, or also if you're looking to see a comparison of all of these systems and learn how to do your more advanced sound driver on all of them, this gives you a good, easy thing to see and a common way that you can see all of the systems doing the same job in a very simple way that you can learn from. So, well, really that's all we're going to be doing today. Well, that's really everything for today. I hope you've enjoyed it. So today we've had a look at the Elan Enterprise, and next week we're going to move on to the Sam Coupe, because we are going to be doing this chibi sound and these sound tests on all of the 8-bit systems that I've been covering. If you liked this video, please like and subscribe, because I will be doing a lot more tutorials in the future. I'm really enjoying making these tutorials, and I think people are finding them useful, so I do plan on keeping creating them. So hopefully you'll follow my channel and you'll see all of the great stuff I've got coming in the future. Thanks for watching today, and goodbye.